Hello students, after the discussion of RES concept, that is the dependence of temperature on kinetic energy. Now I am going to discuss with you a very important things, the another theory that affect the rate constant as well as the rate of reaction. Okay, so this theory is known as the collision theory. Collision theory. Collision theory. So, what do you know about the collision theory? What is the meaning of collision? Students, the meaning of collision is that when the two or more reacting molecules are collide to each other, having sufficient energy, must you remember that. When two or more reacting molecules collide to each other, having the sufficient energy, they get converted to form the products. Okay, so this is known as the collision theory. Must you remember that without the collision, it is not possible to form the product. So it is necessary to form the product, that collision between the reactant takes place. So this theory is known as the collision theory. But the collision between only the effective it means having the sufficient energy that can be collaborate to each other and form a product. So this is known as the collision theory. Students, so what is the collision theory? It means reactants molecule collide to each other, collide to each other to form product. It must be noted that only those reactant undergoes formation of product which have sufficient energy only those reactant molecules undergoes formation of product which have sufficient energy. So collision between reacting species which leads to the formation of product formation of product is known as leads to the formation of product is known as effective collision. Okay, so must you remember that in collision theory, reactants molecule collide to each other, having the sufficient energy leads to the formation of product, and only those reactant atoms undergo the formation of product which have the sufficient energy. Students, what is the effective collision? The collision between reacting molecules that leads to the formation of product is known as the effective collision. Now, another term is also used in collision theory, that is known as collision frequency. That is collision frequency. Collision frequency. So what is the collision frequency? The meaning of collision frequency is that the number of reacting molecules, reacting species react to each other, in per unit time at given surface area, It is represented by Z. Okay, so this is known as the collision frequency. So what is the meaning of collision frequency? Collision frequency is the number of reacting species that directly react to each other per unit time in given surface area is known as the collision frequency. So there are two factors. There are two factors that affect the collision. Two factors that affect the collision. First one is the energy barrier, and second one is the proper orientation. Okay, student. So now I am going to discuss with you energy barrier. Very important topic. Try to understand energy barrier. Energy barrier. Okay. So last time when I taught you collision theory, I told you so many times that only that reactant molecule participate or undergoes the formation of product which have the sufficient energy. Okay, so energy barrier is necessary. So what is the minimum energy required to take part in a chemical reaction is known as what? Is known as threshold energy. Okay, so minimum energy required to take part in chemical reaction is known as threshold energy. Is known as threshold energy. Okay, now this is the threshold energy. Next one is Next one is the minimum energy that required to form activated complex is known as activation energy. It is represented by E. It is represented by E. So here we understood two types of energy. First one is the threshold energy, the minimum energy of reactants that required to participate in the chemical reaction. Are you getting? And similarly, the minimum energy that required to form activated complex, it means reaction intermediate, is known as the activation energy. Okay, so here the activation energy is equal to EA is equal to threshold energy minus average kinetic energy. The kinetic energy, average kinetic energy minus threshold energy gives you what? Gives you the activation energy. Okay, and what is the threshold energy? So threshold energy is equal to threshold energy is equal to initial potential energy. That is the potential energy of reactant. It means initial potential energy plus activation energy. Okay, now I am going to plot very important graphs regarding to the activation energy. So try to understand. Let us consider a reaction A plus B gives C. Okay, so here this is the energy. This is the potential energy of reactant. This is the potential energy of product. This is the activation energy for forward reaction. This is the activation energy for backward reaction. Okay, So this is the now the activation energy is equal to EAF minus EAB. Okay, it means activation energy for the formation of reactant minus the activation energy involved up to the completion of reaction. So here this is the delta H. You know, the potential energy is released. So this energy is released in the form of heat, and delta H becomes negative. The reaction will be exothermic in nature. This reaction is exothermic in nature. I think all of you get this. Okay. Similarly, in other example, another plot you can understand in the same way. Try to understand. Similarly, this is the energy, reaction coordinate, this is the A plus B reactant. C plus T product. C plus T product. So here this is the activation energy for the formation of reacting complex. So students, in this plot, this is the potential energy of reactant. This is the potential energy of product. So here, this is the activation energy, and this is the this is the delta H. So in this reaction, heat is required. Delta is equal to positive, and the reaction is endothermic. And the reaction is endothermic. Now, Boltzmann and Maxwell, Boltzmann and Maxwell also plotted a graph you can see this is the energy reaction coordinate, only this small fraction this is the number of energetic upon number of total, small n upon capital N constant mass, number of reactant molecule upon the total number. Okay, so this is the fraction. So only small fraction of reactant molecules participate in reaction. Okay, now the next one is proper orientation. Try to understand. Proper orientation. Proper orientation. Only those reactant species participate in chemical reaction which collide each other in proper orientation. It is represented by capital B. Okay, so we take example. This is the A, this is the B. These are the reactant molecule. This is the A, this is the B. They are combined, undergoes reaction and leads to the formation of product. While in another example, this is the A, this is the B, this is the V, this is the E. No collision will take place. No collision will takes place. This is the improper orientation. Or this is the proper orientation. This is the proper orientation. So no or less amount of product is formed. Okay, student. Now relation between another example you can also see. Another example, CH3OH, CH3Br, OH negative. This is the partial. Attack on this, no. Improper orientation, because negatively charged nucleophile attack on the negatively charged bromide. So this is the student's improper orientation. Similarly, CH3 Br plus OH negative, this attack on this is the positive, this is the negative. So as this attack, formation of CH3 Br transient one form, and here this type of, this is the OH and this is the Br. Move up. Formation of CH3 takes place. So you can very easily understand about it with the help of this example, that proper orientation is also necessary for the completion of chemical reaction. Now students, next thing is relation between rate of reaction, and collision frequency. Collision frequency. This is the A plus B gives product. So it can be written as R is equal to Z e to power minus E upon R. For the proper orientation factor, it is written as R is equal to Pz e to the power minus E upon I. Now only one thing is remaining in this chapter, that is effect of catalyst on rate of reaction. I will discuss with you in next class with the numerical problems, and in next lecture this chapter will be finished. Thank you, students.